My name is Szymon, and as Tomek said, I've been working in FANDOM as a software engineer for over the last 3 years. And since the very beginning, I am a member of ad engineering team, which is responsible for ad stack on all FANDOM pages. Today, I'd like to tell you how we implemented machine learning models on production and what are the pros and cons of using them on the front-end side. Here you can see the agenda. So at the beginning, I would like to shortly describe our minimum viable product. Then I will move to the implementation of machine learning algorithm in JavaScript. After that, I will move to another project where we use different type of machine learning algorithm. And I will show how to export already trained Python model to JavaScript. Afterwards, I will point out all limitations of running algorithms on the front-end side. And in the end, I would like to show you the alternative, which is the service with REST API. But before we start, I would like to quickly introduce machine learning subject. So we are on the same page. And long story short, it's about creating algorithm that gives you possibility to predict anything you choose to. For example, if you want to predict what fruit is it, as an input to our model, we have to pass a list of features, and those features are describing, in this case, our fruit. It can be color, sweetness, size, and so on. And as an output, we have a prediction, and in case of our question, you may get the name of our fruit, which is an apple, or the probability that it's gonna be apple. Does it make sense? Cool. So let's get back to our agenda and our MVP. In our first project, we wanted to predict whether ad slot is going to be displayed on a page. And in FANDOM, we have main two types of pages. The first one is article page. And on this type of page, in order to display the ad slot, user has to scroll down to the certain position. The second type is home page. And on home pages, we are not displaying ad slot at all, even if users scroll down to the same position. We took those two examples in order to check whether we can easily predict lack of ad slot on home pages, and also get some, let's say, more complex predictions for the article pages. And thanks to that, we could verify whole our pipeline, which was the running the prediction once user enters the page, up to tracking the result to our data warehouse. And in this project, we use logistic regression machine learning algorithm. And now I would like to tell you what it is and actually how does it work. So let's jump to the code in Python, but no worries, it's gonna be short. Here you can see the code, which is responsible for creating and training your logistic regression model. And on the fourth line, we're using fit method in order to train our model. So we are passing the features variables and the response variable. What's important here is that once you train your model, you get its parameters. Those are coefficients and intercept. Those parameters are important because they are needed to calculate the result of logistic regression equation. And basically, the equation looks like this. It's a sum of two variables. The first one is the multiplication of two vectors, vector of our coefficients and vector of our features. Basically, it's called logit function in the math. And the second variable is intercept. Having that, we are ready to implement logistic regression in JavaScript. And here you can see the code. We have a logistic regression class, which takes coefficients and intercept as a in the constructor. And we have our main method, which is predict, which takes the features list to get the final prediction. We are calculating the final result of the mentioned equation, and we are comparing it to 0. Why we are comparing it to 0? Because logistic regression equation gives you positive and negative values. When you have positive value, it means that the probability is higher than 50% that, in our case, slot is going to be displayed on a page. And we are mapping it to 1. If it's opposite, so if you have negative value, it means that the probability is lower than 50% that slot is going displayed on the page, so we are mapping it to 0. Having that, we're ready to use logistic regression in our web application. So once user enters the page, we are preparing the variables which holds coefficients and intercept. We are creating an instance of our logistic regression model, and we are preparing a list of features which is required to fit our model for this specific user. And having that, we are calling predict method, and it gives us prediction. So we can make further decisions based on that. What's good about that is that if you decide to load your parameters from some data source, like MySQL or any key value storage, it gives you possibility to easily tweak your parameters once you retrain your models. And woohoo! We just implemented our first model. With this experiment, we proved that actually we can implement machine learning on the production. We proved that it works. We had expected predictions in our data warehouse. But as you might expect, there's a bunch of different algorithms, machine learning algorithms. So in one of the next projects, we decided to use different algorithm. And let me tell you a little bit about the next project. It was about predicting whether user is going to visit the next page. We wanted to predict that in order to show him some kind of goodbye message. For example, recommend him downloading our mobile app so he could stay with us a bit longer. And in this project, we decided to use the decision tree classifier machine learning model. And now I would like to show how it looks like. Here you can see the example of decision tree, and let's call it fruity tree. And in green leaves, we have our features that we are making decisions on, and in branches, we have the decisions. In order to get the final prediction, we have to resolve single path, and here we can see the example which answers what fruit is it. What we need to do is check the first feature. So we are checking if it's green. Assuming that it's not green, we are checking if it's red. Then and if it's red, we are checking if it's bigger than 2 inches. If it's not bigger than 2 inches, we are checking if it has a stone. And if it has a stone, it means that most likely it's gonna be cherry. In case you would answer opposite in any of previous steps, you might end up with different fruits, and so on and so on. So having that, we might assume that we are ready to code whole algorithm. But at this point, we decided that we don't want to implement whole machine learning framework for running machine learning algorithms on the front-end side. We started looking for existing solutions on the web. And on the GitHub, you can find a project called sklearn-porter. It's a Python library that gives you possibility to transpile your model trained in Scikit-Learn to selected programming language. And as you can see on the screen, here we have JavaScript and decision tree classifier. This is why we decided to try this approach and check whether it works fine. And let's jump to the code, Python again. here we can see the decision tree classifier, which is here we can see the code which is responsible for creating decision tree classifier. And again, we are using fit method, using our features and response variable. So once we have trained model, we are importing our porter class from sklearn-porter library, passing there our trained model and the programming language. And we are using export method, which gives us the output. And in the output, we have code. We have code in our programming language. And on this screen, you can see the main part of the code for decision tree, which is predict method. I wouldn't like to go line by line in this example, because basically what it does, it resolves single path of our fruity tree. So in the end, we are getting the final prediction, which is, in case of fruity tree, it's, for example, cherry. But for example, in our case, where we wanted to predict whether user is going to visit the next page, it gives us information whether he is or he's not going to visit the next page. And it looks like we have everything what's needed to implement our machine learning model, but it's not true because there is the second part of our output code, and it contains the list of parameters which are describing our decision tree. Those parameters create the decision tree structure. And in our case, in this project, where we used 28 features, it turned out that the weight of the features is above 250 kilobytes. So we knew it's pretty heavy. However, we decided to launch it. We rolled it out on the production on some small percentage of traffic, and we proved that it works fine. We also tried to export different model, and it turned out that in this case we went over 750 kilobytes. So we knew that it's not gonna be scalable for us. We knew that's gonna hurt the users which are visiting the page. We also tried to export some neural network algorithm, but it was also pretty heavy on the front end. So this is why we decided to check whether we can have some different solution. And this is why we decided to implement our own service. And now I would like to shortly describe what it does and how does it work. We wrote the service in Python, and assuming that incoming request contains the list of models which we are going to ask for the prediction and list of features with their values, in the first step we are parsing query parameters, we are normalized values, and we are loading models from Python pickle files. After that, we are loading the list of features which is specified for each model, and we are calling the predict method. Having that, we have everything was needed to have the prediction. So we are returning the response which contains all predictions. And at this point, when our web application requests the service, we know all predictions, and again, we can use them to display a goodbye message to our user. In case you don't want to implement your own service, there is a few alternatives available on the web, and one of them is, of course, TensorFlow. And by putting TensorFlow logo over here, I meant TensorFlow Serving package, which gives you whole container with the REST API, and it takes care about models, versioning, and so on. But we didn't decide to use TensorFlow Serving because we were still using Scikit-Learn, and we didn't want to migrate to TensorFlow. There is also TensorFlow.js, which gives you possibility to run your TensorFlow models, for example, in Node.js. But as far as I know, there's other talk later today, which is covering this topic, so I would like to leave it for now. And also there is a bunch of different enterprise alternatives, but at this point we didn't want to, at this stage of the project, we didn't want to pay for those resources. Okay, so that's it, and let's sum up what have we learned. What are the pros of integrating machine learning on the production, on the front-end side of the production? It's an easy way to implement simple machine learning models. You don't need to maintain your own service. You don't need to simply pay for resources. And it gives you possibility to easily tweak data after the training model. But there are also disadvantages, and simply it's not suitable for heavy models on a big scale. It might have negative impact on the page performance because it's running along with your web application JavaScript code. And you need to take care of the implementation machine learning algorithms on your own. Thank you.
The one of the question is, machine learning is a bit tough area to get to, and the question is, any tips for someone who would like to get into machine learning from scratch?
Okay, Coursera. No, you can try going through some courses on Coursera and so on. Also, there is a page called Kaggles, where you can solve existing problems, where you can find existing solutions for those problems, so you can learn based on them.
Okay.
And simply try and try.
So it's not necessary to have a PhD.
No.
In order to get started. Okay,
I don't have.
Okay, cool. So I can finally learn it. There was a question, I think it was asked in the middle of the talk, is that if you were to expose this model to the client, would that mean that someone would be able to steal it, and would it be some kind of security risk issue?
No, because in our case, we created a service which has the REST API, and basically it does the whole logic. It loads the pickle file, which is containing the whole model parameters, and it isn't really exposed to the user which are requesting the service.
Okay, all right. Another question is, if the model is basically just numbers, right? I mean, on my very basic understanding of machine learning, is basically a huge matrix of numbers. If you were to use gzip, wouldn't it make it any smaller, as in you could be able to ship it to the users, or was it simply not enough?
It might help, of course, because it's gonna get smaller size. But it might turn out that you need so much features that it's going to be heavy in this case as well.
Okay. There was one last question I would like to ask is that, did you think about using a web worker to kind of make it parallel from the main thread to make the predictions faster? I mean, right now you are using Python, so it's kind of handled in the backend, but...
Actually, we didn't use the worker, but... yeah, we simply didn't use it. Okay. But it also turned out that user has to download this data.
Yeah, exactly. So you end up downloading it anyways. And you do have a lot of users, so it's probably not a good idea to ship extra code to them. Okay. Yeah. Thank you very much, Szymon. It was fantastic.
Thank you.